next measurement, right? Let's say you want to have a 95% confidence level, right? What will be your range of your measurement value? So basically, this is the normal distribution tells you, right? So the x is the mean, right? And the sigma is the standard deviation, right? So basically, you can say any measurements, right? I have 95% confidence, say my measurement will be in this range, right? So which is mean value minus 1.96 sigma to mean value plus 1.96 sigma. So basically, if you look at the normal distribution curve, right? So let's say we look at the normalized distribution, right? So this is tau, right? The center will be 0, right? Which is the normalized value, right? Okay. So if we look at the probability, right? Probability. So 1.96 is here, and 1.96 is here. Sorry, minus 1.96 here. So we say the probability basically is the integration, right? Is the area under this normal distribution curve, right? This one is 95%. Right? Okay. And if I ask you this question, right? What is the probability from 0 to 1.96? If we only look at this range, 0 to 1.96, what will be the probability? Right? It will be half, right? Because the curve for the normal distribution is symmetrical, right? So the probability under this part, right, it will be 47.5%. Okay. Let me go through one example first. Yeah? So it will be easier. So let's say for this example, right, we have the Gaussian distribution as the mean value, which is 5, right? And standard deviation is 1. Right? Find out the probability that a single measurement, right, from this distribution is between 4.5 to 5.5, right? So for this kind of question, so you want to find out what is the probability within this range, right? Okay? And you can always do a normalization, right? Which is tau, right? And 5.5 basically is 5.5 minus the mean value of 5, right? Divided by 1, right? Sigma. Okay? And this side will be 4.5 minus 5 divided by 1, right? So these are the normalized standard deviation, right? So this gives you 0.5 and this one minus 0.5, right? So how do we find out the probability? So we need to look at the table, right? Yeah. So let me go to the table for the Gaussian distribution. Right. So the Gaussian distribution for 0.5 is here, right? 0.50, right? So it will be 38%. Right? So that means the probability of this thing, right, is 38%. Okay. So how about part B? So part B, so what is the probability my measurement is within this range, which is 4.5 to 5.75. Okay, so again, you need to do a normalization, right? So this one will be 5.75 minus 5 divided by 1, right? So this is this side is the same, right? So this is 4.5 minus 5 divided by 1, right? Then it will be 0.5 to 0.75. Yeah, so if you notice this one, right, here is not, the tau value is not symmetrical anymore, right? So if you draw the normal distribution curve, right? So this one is minus 0.5, this will be 0.75, right? So how do we find out what is the total probability under this curve, right? So this side, what is the probability? 0.5, right? We have the value here, right? So what is the probability for this region? 19%, right? Yeah. So this is 19%, right? So what will be the probability here? So you need to look at the table again, right? For 0.75, what do you have? So for 0.75, 0.7 is here, 0.75 is 54.6%, right? Okay, so half of it will be 27%, 27%. So that means the total probability of this one, right, will be the summation of these two, right? So it's 46%. Okay? Yeah. So for the Gaussian distribution, yeah, you need to be able to do this thing. Okay, so the next one, what is the probability when the x is less than 6.5, right? So again, first you do a normalized normalized deviation, right? 6.5 minus 5 divided by 1, right? So that means this is my tau. This is my tau. Tau less than 1.5. Okay. So this is what does it mean here? So you have a normal. So the center is 0. Here is 1.5. So basically you need to find out what is the probability which is when tau is less than 1.5, right? So what is the probability here? All the way to minus infinity, right? Will be 50%, right? So this one you don't need to calculate is 50%. Because the total area under this curve is 100%. Right? So this is half of it is 50%. Then what is the probability here? Then again you need to look at your normal distribution the table, right? So 1.5 here is 86%, right? So 86%, half of it is 43%. Is 43%. Okay, so the probability of when tau less than 1.5, right, will be the summation of these two, right? So 93%. Okay. So the last example is so what is the probability when the x is from 6 to 7? So when x is 6 to 7, right? So again, first you do a normalization, right? From tau, 7 minus 5 over 1, right? 6 minus 5 over 1, right? So tau will be from 1 to 2. Okay, so what is the probability here? So again, you draw a normal distribution curve, right? I normalize one, 0. So 1 is here, 2 is here. So you need to find out what is the probability here. Okay, how do you do that? So basically, you need to do first you find out what is the probability here, right? And also what is the probability from 0 to 2, everything here, right? And do a subtraction, right? So what is the probability of this one? 1, right? So again, you look at the table, it will be 68%, right? 68%, that means here is half of it, right? 34%. Right? Okay, what is 2? 2 is here, is 95%, right? So 95%, half of it, everything here is what? Is 95% is 47%. Right? Okay, so that means my probability of from 1 to 2 is 47 minus 34. So it will be 13%. Yeah. So this one gives you idea, right? How to find the probability for a Gaussian distribution. Okay. Yeah. So yeah. So this file also gives you the detailed derivation and try to understand what's going on here. Okay, so here are some explanations. Okay, let's go back to the lecture. Okay, this part actually is a bit easier to understand, right? So basically, if you are given what is the mean value and what is the standard deviation, right? So you can tell, let's say 95%, what is my 95% confidence limit, right? So basically, the 95% confidence level for any measurement, right, will be x plus 1.96 sigma, and here is 1.96, right? So this part is a bit straightforward, right? We can do it from the normal distribution flow. But okay, most of the time, right? Actually, the question is the other way around, right? Because we don't know what is the true mean, right? And we don't know what is the standard deviation. Yeah. Yeah. So the question now is actually the other way around. Most of the time we have the measurement data. Right? We have the mean value from the measurement, right? And we have the standard deviation from the measurement, right? And now the question is, what is your true mean? Right? You see the question, right? It's the other way around, right? That's actually, this is the most common question, yeah? Because you have the measurement data, right? And from the measurement data, you need to tell me what is your true mean, right? Instead of I give you what is the mean value, yeah? Okay? So, how do we go from here? So if you have a okay. So now, if you have all the measurement data, right? So last time we discussed, right? You can calculate what is the standard deviation of the mean, right? So this basically is the standard deviation divided by the square root of n, right? And this is called a standard deviation of mean, right? Okay, n is the number of sample data you have, right? And now we can write the confidence limits for the mean value. So basically, now the mean value, right? X bar is the mean value from the measurement, which is known, right? So this is from the measurement. And also, let's assume the standard deviation is known, right? So you can tell my mean value will be in this range, right? I can say this is my 95% confidence limit, right, for my true mean value. Right? So basically, you have 95% confidence to say my true mean is within this range. Right? So you can see the difference, right? Now you get the mean, the average value from the measurement, which is x bar. Right? Then you say, I have 95% confidence to say my mean value will be within this range. Okay, but now the issue is, do we know what is the sigma? What is the standard deviation? And most of the time we don't. Right? So how do we go from here? So we have the measurement data, right? From the measurement data, we can always calculate what is the standard deviation from the measurement data, which is the x sub x, right? Okay, but this x sub x, right, will be a poor, will not be a good estimate, right, of the true value of sigma, right? Right? Because this is Sx, right, is based on the limited number of measurement data. Right? But how does this Sx, right, is related to the sigma, right? So how do we get a 95% confidence limit, right, for such a small sets of measurement data, right? So next we introduce a new distribution, we call it T distribution, right, which is the T distribution. So basically the T distribution tells you, right, if you have the measurement data, right, for this case here is a single measurement data, right, you use your single measurement data minus your mean value divided by your standard deviation, right, and this is your corresponding 95% confidence level of the T value, right? Okay. Or the other way you can write it is you can get your average value from the measurement data, which is x bar, right? You x bar minus the true mean value, like divided by your standard deviation of the mean, right? Again, is within 95%. Confidence limit for the T value. So what is the T value, right? Because apparently T distribution is different from the Gaussian distribution, right? So 95% confidence limit here, it won't give you the 1.96, right? Which is the value for the Gaussian distribution, right? So what is the value here from the T distribution, right? So the T distribution, again, we need to use the table, right? So for the T distribution, we have one more parameter called the degrees of freedom. Right? Degrees of freedom actually is very simple. Basically, it's n minus 1. So n is your number of sample data, right? So let's say, okay, let's look at this table first, right? So this column basically is the degrees of freedom, right? So let's say you have 20 data, right? So what is your degrees of freedom? It will be 19, right? So you need to look at the degrees of freedom 19, right? So what is the corresponding value? So here is the probability, yeah, like 90%, 95%, 99%, so right? So if you want to look at 95% probability, so degrees of freedom is 19, then what is the corresponding value for T? What is corresponding T value? It will be here, right? Okay, never mind. We can later we can look at one example you see. But the key point is, if this is the degrees of freedom, right, approach infinity. When this degrees of freedom approach infinity, right? Basically, the T distribution becomes the Gaussian distribution. Okay, so if we look at the degrees of freedom, which is infinity, right? So 95% of 95% confidence limit actually is 1.96. So that means when the degrees of freedom approach infinity, the T distribution becomes Gaussian, right? And when the sample size is small, you can see the T value actually has a much bigger. It has a much bigger value than the Gaussian distribution. Right? Gaussian distribution for here is 1.96. Right? So if let's say you have 10 samples, the T value actually is 0.22. So it's really quite compared to the Gaussian distribution. Okay. So here are just some examples here, right? So if let's say your sample size is 6, right? So the T value for the 95% confidence limit is 2.57. If it's 31, so the T value becomes smaller. When T goes to infinity, the T actually is the same as the positive value of high. Okay, so if we rearrange the equation above, right? So you will get the following two equations. So what does these equations tells you? So basically, so now the question. Okay, let me repeat. Why we are doing this, right? So now the question is, you have the measurement data, right? So you want to estimate what is my true mean, right? Okay, so true mean value is this one, yeah? So the true mean value will be within this range, yeah? So let's look at second equation first, right? So we'll be within this range. With 95% confidence limit. This is my 95 confidence limit for the true mean. So this X bar will be your average value from the measurement, right? And T is the corresponding T value, right? That's how we talk about from the T distribution, right? So XX actually is the standard deviation from the measurement data. Also, you can calculate that as long as you have the measurement data, right? You can calculate what is the SX, right? And square root of n, n is the sample size, right? So basically, this is what? SX divided by square root of n is what? It's your standard deviation of the mean. This is your standard deviation of the mean, right? So that means for this one, right? For this one, I have 95% confidence, right, to say my true mean will be within this range, right, which is from X bar plus minus G95. G95 is the T value for the 95% confidence, right? Then comes the standard deviation of mean SDOM for this set of measurements. Okay, and the other equations, basically, you can use the other way around, but you can use the single measurement data, right, plus. So this is a single measurement data. Right? This is your average value of your total measurement data, all measurement data. Right? This is a single measurement data. Again, you use 95% value for the T, right? So here, because it's a single measurement data, right, you have to use SX, right, instead of the standard deviation of T, right? And minus T95, right, SX. Okay, this one also gives you the 95% confidence limit for the basically you have 95% confidence to say my true mean will be in this range if you use a single measurement data, which is the xi plus minus t95 times sx. Okay, so this part will be a bit difficult to understand. Let me show you one example, probably will be easier. So let's look at the example here. Let's say you have one okay. So for these examples, right, you have you need to do an experiment, right? So 24 students measure the temperature, right? Okay. So the mean value of the 24 measurements is 97.22. Okay, this is the mean value of the 24 measurements. And the standard deviation of the sample is 0.085. So this is the standard deviation from the 24 measurements. Right? So the first question, determine the interval, right? With 95% confidence, what is the mean value of this limiting Gaussian distribution? If you see this question, right? So you have 34 measurements from the students, right? So the question asks you, what is your 95% confidence limit of the true mean? Okay? So the first thing is you need to find out what is the corresponding t-value for 95% confidence limit, right? So here you have 24 measurements, right? So what you need to do is you need to go to the t table, right? You need to go to the t distribution table, yeah, here. So which degrees of freedom you need to look at? 23, right? Yeah. So you need to look at 23 and 95% confidence, right? So here is 2.069. So that's the T95 for this case, 2.069. Okay. So let's come back to here. So we can put down our value here. So T95 for this case will be 2.069. Right, for the degrees of freedom, which is 33. Great. Yeah. Okay. So you want to determine what is the interval, right, for the mean, right? Okay. So this is your true mean, right? Okay. So for this case, you know what is the average value of the measurement, right, which is 97.2, right? M plus 2.069. Okay, so the standard deviation is given, right, 0.085, right? And you need to divide by square root of 24, right? So this one gives you the SEOM, right? This is SEOM, right? And the lower bound is, again, is 97.22, right? So it's minus 2.069, right? Times 0.085 divided by square root of 4. Okay, so this gives you the 95% confidence limit of the mean value. Okay. Yeah, this part you need to understand. It's important. Okay. So next one. Let's look at the part B. So part B basically tells you you take one additional measurement, right? Okay. So the measurement is 97.25. So within what range on either side of the measurement will the mean of the limiting Gaussian distribution form with 95% confidence. So this actually is the other type of question, right? So now you have only one measurement, right? You have only one measurement. Again, you look at these two equations we have, right? Yeah. So you need to use the second equation, right? So because this one we look at one measurement, right? So one measurement now is 97.25, right? Right. The T95 is the same, right? T95 is the same. And now you only need to use the standard deviation, right? Which is 0.085, right? You don't need to divide by square root of n, because you use a single measurement here, right, to estimate 95% confidence. Okay, so again here 97.25, right, is minus 2.069, 0.025. Okay. Okay, so basically these are the two ways the question can ask you, right? The first part is the question say, okay, you are given the average value from the measurement and the standard deviation of measurement, right? And you need to estimate what is the 95% limit, confidence limit for the mean, right? And second part basically is you are given one additional measurement, right? That's a single measurement, right? Okay. Then you can estimate what is the confidence limit for the two mean frequencies. They are type of questions. Okay. So again, you can look at your solution here, right? Right. So if you include there's a different result here. Okay. So we have discussed how to find out the confidence limit, right, for the true mean, right? So next, we need to look at how to reject certain measurement data, right? Let's say we have 6 measurements here, right? So if you look at the result here, right? So apparently the last result has some issue, right? Right? So you just do by a simple inspection, right? You notice that actually the last one has some issue. But can we reject this result? Yeah. Can we simply throw away this 1.8? Right? Yeah. So we need to have some tool to do that, right? Yeah. So we need to establish certain rules to reject this kind of results, right? If whether this is reasonable or not, right? Okay. So the result, this kind of result, it could be because of something wrong with the experiment, right? Yeah, maybe the equipment failure or some errors or mistake. So we have to check if this result makes sense. But the first thing, we should never throw away this kind of results. Right? We need to do some proper checking. Right? So we have this criterion called Chauvet-Neff criterion. Right? So this one we will this criteria basically let us to decide whether we can throw away these outliers, right, from the measurements. Okay, so let's say we have a data set, right? We have n measurement values, right? Okay, so once we have these n measurement values, right? So that corresponds to a probability which is 1 minus 1 over 2n, right? So we have n measurement data, that means the corresponding probability of 1 minus 1 over 2m should be retained, right? All these values, right, within this range should be retained. What does it mean? Okay. So we have normal distribution, right? Right? So any value fall within the shaded area, right? So this area basically has a probability of 1 minus 1 over 2n. Right? So if any value within this area, we should retain. Right? Outside this area, we should reject. So basically, that's the graph tells you. Okay, so let's say we have 6 measurement data here, right? So the probability, if you calculate 1 minus 1 over 2m, right? It gives you 95%, 92%, right? 92%. So basically, now if you look at the Gaussian distribution table, right? So what is the corresponding half for 92%? What is the corresponding half for 92%? So for this case, it will be 1.73. So that means any measurement data which are from minus 1.73 to 1.73, right? We should retain. Outside this range, we should retain. Alright, you get the point. Okay. So you can see, right, the probability in this Chauvet criteria, right, is depending on the sample number of measurement data, right? Okay. So let's look at one example. It will be easier, right? Okay. Okay. Let's say we have this. Let's say we have this measurement, right? We have how many measurements? We have 5 measurements, right? 5 measurements. Then we can find out. We can always find out what is the average value and what is the standard deviation, right? Yeah. So this is straightforward. Right? Okay. And if you simply look at the data, right, you will see all these are 60 something. This one is 40 something, right? So you can see actually this data point has some issue, right? But now the question is, can we reject this data? Right? So we need to use the this Chauvet criteria, right? So first we can do a normalized deviation, right? So you can use the measurement data minus your mean, right? Divided by your standard deviation. So this one gives you the normalized deviation, right? Okay. So next, you need to apply the Chauvet criteria. Right? So for this case, we have 5 measurement data, right? So 5 measurements data corresponds to the probability which is 1 minus 1 over 2 times 5, right? So which is 90%, right? So 90%, then you look at your Gaussian distribution table, right? What is the 90% corresponds to? So it will correspond to the 1.65. Okay. So for this example, right? So because n equals 5, right? So we need the 95%, right? Probability. So we need 95%. Sorry, the 90%. Because this is the Chauvet equation tells you. We need 90% here. Right? So 90% corresponds to tau, which is 1.65, right? This is 0 and this is minus 1.65. Okay? So that means any data within this range, right, we need to retain. Outside this range, we need to reject, right? So just now the data we are looking at, which is at 1.78, right? So which will be here, right? So which is 1.78. So this data now is outside the range, right? So we need to reject this data. Okay? So this is the way we decide whether we should retain or reject the data. So what happens if we reject the data? So after we reject the data, right, we need to recompute the mean value and the standard deviation again. Because basically, if we reject the data, right, basically we say this data is wrong. Right? So we should not include the wrong data in our measurement. Okay, so here, basically, we use the Chauvet criteria and say, okay, this data we should reject. So after reject the data, we need to recalculate the mean value and the standard deviation again. So you can see actually there is a big difference from previous measurement. Right? Basically, in the earlier calculation, right, we include one wrong point. That's why your data is altered. Okay, let's look at the other one, the other example. So we have 10 different students, right? And do the measurements of the pressure, right, in the system. So now we have 10 measurement data, right? So once we have the 10 measurement data, we can calculate again. Yeah, we can calculate what is the mean value and what is the standard deviation for these and data points. Right? So if you look at the individual measurement data, right, you will see this 1.55, right, be wrong. But we are not sure whether we should reject or retain. Right? So we need to do a proper checking, right? Using the Chauvet criteria again, right? So for this case, n is equals to 10, right? So if we use the Chauvet criterion, the probability for n equals 10 will be 95%, right? Which is 1 minus 1 over 2 times 10, right? 95%. So 95% for the Gaussian distribution corresponds to tau, which is 1.96. Okay, so so again, for this example, right, we say because n is equals 10, right? So we need 95% here, right? According to the Chauvet criteria, right? So that corresponds to 1.96, 0 and minus 1.96. So basically, any data, if it fall within minus 1.96 to 1.96, it will be retained. Right? So let's look at the what is the normalized deviation for this 1.55, right? So 1.55, yeah, if you normalize, so it will be 1.55 minus 1.14, which is the mean value, right, divided by your standard deviation 0.15. Right? This is your normalized deviation. So this gives you how much? So it will be 31, right? So it will be 0.2 something, right? 0.2. How much is it? This one probably is 2.7. Sorry, this is 2.7. point something, 2.1 something, about 2.1, right? So standard calculation is correct? Oh, okay, it's a 4.1, right? Okay, 2.73. Okay, so 2.73 will be here, right? Yeah. So 2.73 is here, which is outside the range, right? Reject, right? It's not really reject. Okay. So after reject this data, right? Now we have only 10 matching data, right? So you need to recompute, right? You need to recompute for mean value and also the standard deviation. Okay. So any questions so far? This part again, we have this file in the Moodle, right? So you can do some exercise, right? So again, it will be a good exercise for you, right? So let's say you have this measurement data, right? Do you get the same standard deviation, right? Because basically you need to know how to use your calculator in Excel, right? So if you are given, let's say 10 data, right? What is the standard deviation? Right? You need to be able to find out the standard deviation. Okay? And after rejecting the wrong points, right? You need to recalculate again. So what is the mean and what is the standard deviation? Right? So yeah, so that's all for today. Okay.